So the next talk is by Gannon, Chainspotting Part 2. Enjoy the talk.
There it is. Okay. Hi. Chainspotting 2, the unofficial sequel to the 2018 talk Chainspotting. Very long title, but the summary of this talk is building an exploit chain with logic bugs for Ireland Pwn2Own 2024. Real quick, there it is. I am Ken Gannon, or Ken Ito, depending on which country you're from. At the time of this research, I was with NCC Group. Now I'm in Japan doing security stuff, and occasionally I like to do phone stuff. I've been attempting Pwn2Own actually since 2020. I have a failed attempt in 2021, successful in 2022 and 2023 and 2024. Last year I did a talk on the Xiaomi 13 Pro hack at DEF CON. This year I'm talking about the S24. So Pwn2Own Ireland, I'm sure everyone here knows what Pwn2Own Ireland is. The fun part is that there were 28 devices in scope, 3 mobile devices, thank fuck for no Xiaomi, and 25 non-mobile devices, which included printers, cameras, smart speakers. WhatsApp was also in scope for this year. I targeted the S24 because I have an obsession with Android and Samsung, apparently, and I just like Samsung. I can't help but say it. But there were only one phone entry the entire time. There were 61 entries targeting IoT and SOHO devices, and I was the only phone entry. Neat. But why? Why the fuck was I the only phone entry? So, to give a little history on hacking the Samsung devices for Pwn2Own, the Galaxy App Store was usually the method to hack the phones. In 2023, it was the Galaxy App Store that was used to pwn it 4 times. And then in 2022, again, the Galaxy App Store was used to hack the S22, again, 4 times. My own failed attempt from 2021 also used the Galaxy App Store as an initial entry point. So what does this mean? Well, the approach to attacking a Samsung phone is actually really simple. Step 1, you decompile the Galaxy App Store. Step 2, you look at the source code. Step 3, you realize that the install code is missing. What the fuck is the install code? Well, here's an example from 2023. This function in the Galaxy App Store was a JavaScript interface that was used a lot to hack the phone that year, and this is what I call the install code. In summary, this code allowed the Galaxy App Store to automatically download and install any application from the Galaxy App Store without user interaction. And this code and variants of this code was found throughout the Galaxy App Store in 2023. In 2024, it's gone. The entire app, all install code, all automatic install code was stripped from the Galaxy App Store. The only way you could install apps that year was through physical interaction from the user, which is not allowed. So what the fuck do you do here? Well, for me, I had 2 options. Option 1 was to find issues on the Samsung servers themselves and try to finagle my way that way, or find issues on other Samsung applications. The first one, web app stuff. We all know how to do web app penetration testing. It's very easy, but whenever you send stuff to the Samsung servers, they get a log of everything, and I do not want them to know what the fuck I am working on. On top of that, I was living in the Philippines at the time, and I cannot stress this enough. The quality of internet there really depends on the month of the year. I will leave it at that. The other issue, the other side though, is that if you look at all the Samsung apps or the Google apps on the phone, the good news is that Samsung can't as easily see what you do, but there's a lot of fucking apps on that thing. And I suck at coding, and I suck at automation, but I do hate myself. So in the end, I chose to look at all the apps on the phone instead. And the plan is going to be simple. Step 1, you find a browsable intent to try to get initial entry. Step 2, you do some fucking magic. And then step 3, you install and launch Drozer. Sounds very easy. It is not. So several months later, I come across the first initial entry point in the Samsung Gaming Hub. This is the first app that I ended up exploiting. So what this app does is that it allows you to browse the games that are available on the Galaxy App Store, and also allows you to play cloud-hosted games offered by Samsung. The version I pwned was 7.1.0.7, and other information about this app is that it contains some web views. It does have services running in the foreground. It does have Samsung custom permissions on it, so there's some cool stuff going on over there, but it cannot install applications. So whatever I found in here, it's not going to be the full chain because I cannot install Drozer with this. But the first bug I found with this app was that there was a web view in that application that can be forced to load any URL in the web view. Yes, I mean any URL. There was absolutely no URL filtering whatsoever. Very simple, very easy. The exploit code is actually really easy. All you do is just set up a web server, host this browsable intent, and have a URL parameter point to whatever URL you want to load. Once a user clicks on that, boom, web view is open. Here's a web view that had NCC Group's website on it. Proof that I was loading the URL in that application. So cool. We have our first bug. So again, step 1, click browsable intent. Step 2, launch the URL. But so what? You're loading a URL. Who gives a fuck? Well, let's look at bug number 2, a URL check bypass. So the web view did check for URLs. Do not ask me why it only checked the URL for loading JavaScript. I have no idea. But there was a URL check that if it matched a specific whitelist, then JavaScript would be enabled. This one was a little bit harder to find. So over here, we have the code that is in charge of building the web view that we're currently looking at. And all the way down here, we can see that JavaScript can be enabled at this function over here if this function returns true. And to make this function return true, we have to make this return true. And to make this return true, we have to make this return true. That's why it's 3 different true statements we have to go through. And to make that return true, we come across this function. This is a Kotlin string starts with string. And what I found is that the application checks if the URL starts with one of these values. If you look closely, only some of them have slashes at the end. So what does this mean? Well, this means that we can register a domain that starts with any of these URLs. So you know what starts with HTTPS? Well, I'm not going to say it out loud. You know what starts with that URL? My own custom URL. Cool. So now we can get JavaScript enabled. Again, the payload, very easy to do. You just update the target URL with your own custom URL. And there's a proof that I have started it with that domain. And there, we got JavaScript running. All right, cool. So now we have a little bit of a nicer chain. Step 1, click on the hyperlink. Step 2, load my custom URL, and JavaScript is loaded. But wait, there's more. Because now we come across the third bug in this one web view. The gaming hub could be forced to execute start activity against any intent object that you, the attacker, controls. So in other words, you, the attacker, can force Gaming Hub to launch any exported activity on the phone. How did this work? So going back to the web view code, this function right here gets executed whenever the web view receives a 302 redirect from the web server. And what happens is that when this gets executed down here, it checks if the new URL starts with the intent scheme. Instead of HTTPS or HTTP, it'll start with intent : // right? Once it passes that check, the URL gets sent to this function down here, and the intent URI is converted to an intent Java object. Neat! We can craft our own intent Java object, And then that intent object is passed over here down to start activity. Yay! Now, the fun part about this is that, as I said, I have JavaScript enabled, which means I can now craft a JavaScript script that will consistently make GET requests to my web server. And my web server will always respond with a 302 redirect, which will then force the gaming hub to automatically launch whatever activity I launch. But JavaScript still runs in the background of the app. So I can continually use JavaScript to force the app, to force Gaming Hub to communicate with my web server. And then I tell the web server to tell Gaming Hub to open a new activity. I'm just opening up new activities, this and that, and this and that. So I have what I like to call a tiny C2 channel against Gaming Hub now. So the payload for this, very easy. All you have to do is, well, not really change it. I actually only added one part, which was, there it is, which is right here, where I now tell Gaming Hub where my Python web server is. Because my Python web server is going to be my little C2 server that tells Gaming Hub what activity launch, right? Over here is the JavaScript that I hosted on my custom web server. And then over here is my Python Flask server. So we have a few things in here. You know, we have index, we have yay launch yay, we have Pichu dance because, you know, Pichu's awesome. The key part is that when Gaming Hub tries to make a GET request to my web server and it ends with yay launch yay, it is then going to force Gaming Hub to launch Drozer because it's going to respond with a 302 redirect and an intent URI that then converts into an intent object. But we don't have Drozer installed yet. We're not there yet. All I have right now is the ability to launch any exported activity I want. But we have a plan. We have a nice, bigger plan now. Step 1, user clicks my malicious link. Step 2, it goes to my web server with JavaScript. Step 3, I tell Gaming Hub to launch any activity I want. Step 4, magic, install Drozer. Not a full chain. But I now have the ability to launch any exported activity. I cannot stress how important this is in Pwn2Own. Now, the good news is that I am no longer limited to just looking at browsable intents. I can look at any exported activity I want on that phone. The fucking bad news is that there's a lot of shit on that phone. Beforehand, there were only 413 different browsable activities to look at. Now there's 2,219 different exported activities I have to fucking look at. It's a lot. And again, I suck at automation and I suck at coding. So what felt like an eternity later, I have bug number 4 on app number 2, Samsung Smart Switch Agent. So a little background about this application is that Samsung offers the ability to transfer your data from one phone to a new Samsung phone. It's called Samsung Smart Switch. Yeah, Samsung Smart Switch. And there's 2 parts to it. The Samsung Smart Switch, which is like the UI of the application, and Samsung Smart Switch Agent, which is like a background service. The background service is what I ended up exploiting in this chain. Version Pwn was 2.0.02.24, and a little bit of information about this app. It can install applications, so that's good, but there are no web views, and it only has one exported activity, so that's only really one thing I have to look at. And it does not have access to the SD card area of the phone. That is important. We'll come back to that later, I promise. So how did I exploit this app? So over here, like I said, it has one exported activity, but it's protected by a custom permission that I don't have the ability to. Well, it's a Samsung custom permission, right? Thankfully, Gaming Hub happened to have that custom permission. So it just so happened that the app I was exploiting was able to open this one app on the phone. Cool. So the bug I ended up exploiting on this app is that I could install any APK that resides on the disk of the phone or that is hosted from an exported content provider. And the issue is that Quick Agent does not check the signature of the target APK. So it will just blindly install any APK that you feed it. So let's talk about this code real quick. Over here, we have the intent string extra SSM URI, which gets saved to that one location. The SSM URI is a parameter that you guys, the attacker, would have provided to the application, and that URI must start with either file or content. Because again, the APK could be either on disk or in a content provider, right? Once you have that, the application reads the URI that you provided, and then the application will automatically reach out to that URI and try to download it to its own private directory. And then that application, or that APK that you pointed it to, is then saved into the, like I said, the private files directory, but as smartswitchmobile.apk. So it gets renamed to smartswitchmobile.apk. With this, and combined with logcat stuff, it was pretty obvious that this application was meant to be like an update or some other like Samsung developed application. But again, for some reason, Quick Agent did not check the signature. So to exploit this issue, we just need to tell Quick Agent to go download my Drozer APK file. But I still need to put the Drozer APK file on disk somehow, and I still need to, or I can host the Drozer APK from a content provider. So we don't have a full chain yet, but at the very least, I now have a way to arbitrarily install any application that I want on the Samsung Galaxy S24. Okay, so we got to update our code a little bit. Over here is there's a web server that I host on my custom web server domain, and this is some added stuff to the JavaScript. It will try to reach out to, again, my Python web server, and it will try to launch yay install yay. And after 15 seconds, after 15 seconds, it will then launch Drozer. And over here, we have updated Python. Wow, that is small. I apologize. But essentially, over here is where we would put our SSM URI, but we don't have Drozer on the disk yet, so we don't have a full exploit chain yet. But here's a placeholder. We like placeholders, right? That means we're almost there, sort of. And over here is the yay launch yay. Again, though, we don't have Drozer. But we do have a nice plan. Step 1, user task will have malicious hyperlink. Step 2, website gets loaded. Step 3, I tell Gaming Hub to go and reach out to something. No, I'm sorry. I get Drozer on the disk somehow. We're not there yet. I don't know how, but we got to do that. And then I tell Gaming Hub to tell the phone to launch Quick Agent, which then reaches out to the content provider or downloads the APK on disk, and then install it, and then we're good to go. We launch it. Oh, we're so close to a full chain, aren't we? We're only 4/5 of the way there. Now, we do have one more issue, though. There's now more shit I have to look at. Because, as I said earlier, I have to look at exported activities, but now I have to fucking look at exported content providers as well. I have to see if there's any content provider on the phone that I can use to hopefully get Drozer onto the disk, or something I can use on another app to get to host Drozer onto the Quick Share agent. So in total, I had to look at 2,561 different fucking exported components on this thing. But I did find two interesting things that I want to talk about real quick. A little bit of side tangent. The first one was GPU Watch. This application came with every single flagship phone, and still does come with every single flagship phone on the S24 or Samsung. Samsung flagship phones, and you can use it to debug your games. It's what its primary purpose is, and it does host an exported content provider, and it stores log files at SD card GPU Watch HTML. All the log files that this application generates will sit in that folder, and then anyone can reach out to that folder or that content provider and download the logs. This is not an exploit. There's a reason I mentioned this. Just hold on to this thought, all right? The second thing I found was Google TV, and I just want to point this out because I thought this was really funny. There was actually a path traversal issue in Google TV. I did not expect to find that. But I could only exploit it if the linked Google account was linked to a Google family, and the family group had purchased movies or TVs in the past, and Google TV had previously been opened in the past and went to the highlights section of the application. Very weird prerequisites, but in the end, that's my report right there. Just got a, little dot, dot, slash, and you can read any arbitrary file, right? So what if this is it? What if I get Drozer on the device and use this as a way to point QuickShare Agent to download my APK file? Well, with some JavaScript fuckery, it was possible actually to get the Drozer APK onto the disk. So all I have to do is tell Google TV using this exploit to reach out to that one APK. It doesn't fucking have access to SD card. Thank you, Google developers, for making sure that this application was secure and I could not use this in my chain. I was so pissed at this at the time. Holy shit. Now, to give some context, I found this in October, the beginning of October. Pwn to Own is 2 weeks away. It is 2 weeks away from when Pwn to Own starts. I do not have a full chain yet. I am 4/5 of the way there. I am racking my head around what the fuck do I do? I don't understand why none of this is working. I can't find anything. So now I'm looking. At this point, I'm done looking at exporter content providers. I'm now going back to looking at exporter activities. And I come across this. The application Samsung QuickShare. So Google has implemented, or Google and Samsung has implemented their own version of Apple AirDrop, which is a way to transfer files from one phone to another, no compression whatsoever. Samsung originally developed it, I believe. So now at the time, Samsung did port over QuickShare to the main Google image, but at the time it was still kind of like early stages. So that's why we're going to focus on Samsung QuickShare. And even nowadays, Samsung QuickShare is its own thing. And the unique part about Samsung QuickShare is that you can you can use Samsung QuickShare to share files with a QR code. I don't know if this is implemented in the Google version. I just know that this is something in the Samsung version. And the neat part about this is that the activity which receives a QR code is exported. So that means that any application on the phone can reach out to that exported activity, provide the QR code data to that activity, and the phone will automatically download whatever file was hosted at that QR code. This is by design. So this is an example. You share a file with a QR code, and you have the little QR code right there, and you put it in. Oh, yeah, it's also a browsable intent too. So you could literally just like tap and then force the phone to download a file from another phone that's nearby the victim phone. Neat, right? Cool. Again, this is by design. Now, again, this is really fucking cool. I already have the ability to force the phone to open any export activity on the device. I could just open up that one activity and force the phone to download the APK from my phone. Cool. Except the phones are placed in the fucking SD card area of the device. And once again, as I said, QuickShare Agent does not have access to the SD card. Google TV doesn't have access to it. QuickShare Agent does have access to it, but Google TV does not. And Smart Switch Agent does not have access to the SD card. Remember I told you to keep that in mind? Again, I have no way access to the SD card right now. Oh, this sucked. This sucked so hard, my guys. But, it's a cool bug. It is now late at night. I go to bed. It's a cool finding, though. The transfer probably happens over Bluetooth. These are the thoughts I'm thinking in my head. It's interesting that the phone automatically connects to an attacker's phone. Connects to an attacker's phone, right? Attacker-controlled phone. And I wake the fuck up and I realize, wait a minute. It connects to an attacker-controlled phone, but so then can the attacker control where the file gets saved on the target device? Let's talk about bug number 5, Samsung QuickShare Agent. So just like with the Smart Switch agent, there are two parts to this application. Again, QuickShare is the UI. QuickShare agent is the background service. Version I pwned is 3.5.19.33. And other important information. No, we don't have time to go other important information. Samsung, pwn to own is 2 weeks away. I need to figure out what the fuck's going on with this. And so I did. At a high level, after some reverse engineering, at a high level, this is essentially how Samsung QuickShare shares files. A socket connection is first established between the two phones. Then the attacker phone transfers or sends some transfer information to the receiver phone. After that, the attacker phone sends file information to the receiver phone. Then the file is actually sent to the receiver phone. Then the receiver phone saves the file to this area on the phone. And then the file is moved to this other area on the phone. And then finally, a closed message is sent from the attacker phone to the receiver phone. This part was interesting because, again, the goal is to see if I can control where the file is either saved to or where the file is copied to. So over here, we have, again, we're going back to the file information data that is on, the file information part, right? We have the file name. What if I just add some periods to that? What if I just do a simple path traversal issue on that? Here's a Vrita script that did that. It hooked into the proper function. It altered the file information. And if the name started with yay.apk, just add some, path traversal. You all know what path traversal is, right? So let's do it. What the fuck is that? Where the fuck did those dashes come from? I haven't slept, by the way, at the time, well, both now and at the time of this research. But at the time of this research, again, I woke up, I got out of bed. I was like, how the fuck do I do this, right? Well, this, again, pissed me off. Thank you, Samsung. And when you look through the code, we have over here, hey, look, there is some code with some regex that takes the period, period, slash, and then converts it to period, period, dash. But we also have this part up here. There is no filtering up here. What the fuck? Why is there no filtering up here? How do we get up here? Okay, how do we get up here? Well, we make that return true. We make that return, we have to make that return true. So, I'm coffeeed up at this point. Let's try to figure out how this works. To make this return true, we make this return true. And to make this return true, we have to make the H has to be set to, J has to return true. No, I'm sorry, yeah, H has to be set to true, right? And to make H be true, J has to execute. And what executes J? The argument of whatever is based on is private share. What the fuck is private share? So another quirk about the Samsung QuickShare specifically is that there are actually two ways to share files between Samsung phones. Samsung phones. The normal way is that, the whole QR code file gets uploaded to a web server. The QR code can be sent to another person so they can download the file. It's all normal stuff, right? The private share means that the phones will use, and I'm quoting Samsung here, blockchain-based encryption technology to make sure that the file is securely transferred between the two phones and the file is not uploaded to Samsung servers. I have no idea how private share works. I did not look into this. Again, it is now like 3 a.m. I have work the next day. What I really want to know is, how the fuck do I make this return true? Well, apparently, is private share is just a parameter in the information, the transfer information packet I was talking about earlier. So all you have to do is make that return be true instead of false. Simple, right? So we did it. We now have the ability to write to force the victim phone to write our file to any location that we specify. But what location? Oh, that's a spoiler. All right, whatever. Yeah. So, but the problem is that, again, Samsung phone. It has to be between two different Samsung phones because private share is a Samsung phone specific feature. So I had to use a Samsung phone to pwn a Samsung phone. which I think is really fucking cool. In fact, if you look on stage, here's an unreleased photo of me and Putor. Shout out to him. Over there is the Target S24 phone, and over here is my rooted Attacker S24 phone. I specifically made sure that there were no pictures of this whenever ZDI released their media because I did not want to spoil this part. So that's right, you needed 2 phones to hack the Samsung S24 last year, or I did. And how do you make, you make is private share equal to true using a Frida script. You all know how to use Frida. But where do you save it to? You remember GPU Watch, how it hosted a content provider that any application can reach out to, and you just place whatever you want in that folder, and then any application can reach out to that content provider? Well, that's where you fucking place it. And there it is. There is the part of the code that will make the victim phone save our APK file to the GPU Watch location. And exploiting this was actually really, really cool. You know, here again, here's the APK file that can be downloaded from the GPU Watch content provider. So now we have our updated final exploit code. Again, this is the HTML that gets hosted on my public web server. And over here is now we have the last step. We launch Share Live and download the file, and then count down for 15 seconds before we install it, and then launch Drozer, right? And here is the final Python web server, which again, we now have updated code that forces the victim phone to download my file. The Yay QR code, Yay parameter is just the QR code data. Once it downloads the file, it will then install our application with QuickShare Agent. With the other agent, sorry. And then we launch, that's the URI of the APK that's going to be saved on disk. And then, we launch Drozer. So we have a full chain, right? Step 1, user taps the hyperlink. Step 2, my web server is loaded into the web view. Step 3, Gaming Hub reaches out to my web server and I send it through to redirect. Step 4, launch QuickShare Agent to download the APK file from my nearby phone. Step 5, again, Gaming Hub reaches out to my web server. Step 6, I use my web server to tell Gaming Hub to launch Smart Switch Agent, which then installs the Drozer APK from GPU Watch. Step 7, I tell Gaming Hub to, Gaming Hub once again makes a GET request to my web server. Step 8, I tell Gaming Hub to launch Drozer. And step 9, you win $50,000 and you scream at the top of your lungs because you hacked the S24 for Phone to Own 2024. Yay! Now it's demo time, hopefully, because I have 2 phones up here. The left phone is the victim phone. Actually, so fun fact, for Phone to Own, whenever you hack a device, they give it to you for free. This is actually the phone that ZDI gave me. I specifically made sure to keep it on a version of everything that was still hackable for this exploit. And if it doesn't work, I'm sorry. On the right is my attacker phone, and we have our little Python web server at the top right. And the bottom right is going to be, I'm going to use that as a way to connect to my victim phone with Drozer. So what I need to do, first I need to share this. I need to make a QR code. And then I'm going to copy the URL because I want the little QR code thingy down here, right? Off screen, because I don't like sharing everything on my screen, I'm going to take the QR code data. I'm going to put it on the web server. Save it. There we go. All right, 3, 2, 1. I'm going to have the victim tap the little button above Pichu's head. And there. So, as you can see, QuickShare Agent launches. QuickShare Agent then is forced to automatically, I'm over here by the way, is now connecting to my attacker phone, downloads the file, and then Smart Switch is installing. Again, Smart Switch is installing. And then Drozer's launched. Yay! Over here on the right, we can see the different API or the different HTTP endpoints that my phone was connecting to. And last step, we kind of need to show that we can do, code execution, right? There we go. Yay, demo. We did it, boys. Demo's live. All right, that's it.